Hello everyone. Hope you all are safe and healthy. So let's start. In the last lecture we have seen about the transaction management. Okay, in that we have taken ATM card transaction example. Also we have applied transaction management properties, that is asset properties, that are atomicity, consistency, isolation and the durability. Now next topic is serializability. This is very important topic in transaction management. So what it defines? It defines as a schedule of S of n transaction is serializable if it is equivalent to some serial schedule of the same n transaction. In a simple word, what is this? Whatever the schedule is, it should be in the form of a serial. Now, what do you mean by schedule? Schedule is number of a transaction. Okay, suppose we have one schedule. In that we have two transaction. In transaction management, we have seen two operation, that is read and write operation. Similarly, transaction 1, apply read and write operation on account A. In transaction 2, same operation will be done, that is read and write operation. Now we will draw one graph for this schedule, that is T1 and T2. Now what happened here? Read and write operation perform in T1 transaction. Okay, then after finishing this transaction it goes to T2, right? So simple, the transaction or schedule ends here. Now if there is another operation like read account B, then how we will going to draw this diagram? That is, suppose T1 first transaction, T2 the another transaction. This whole process is called schedule. Now what happened? The transaction 1 will perform read operation on A account, write operation on A account, then it will goes to transaction 2. Then it will goes to transaction 2. It will apply read operation, write operation. Again it will goes to transaction 1 to perform read operation. It will goes to transaction 1 to perform operation. Now this is called another schedule. Now what happened here? Here you can see there is no loop is created. Only a one line schedule is there. But in this schedule what happened? There is a loop, right? So this loop, or it is called parallel serial, where this is called serial schedule and this is called parallel schedule. Okay, now how to solve this problem? We need schedule should be in a serial form, right? So when a schedule perform or occur some loop or it is in a parallel form, so what will be the solution for this serializability is what? It is conflict serializability. So there is two type of serializability, there is conflict and view. So let's see what do you mean by conflict. Now the definition of this is if it is conflict equivalent to a serial schedule. Now first what we will do? We will search which pairs are conflict and which pairs are non-conflict. Okay, now conflict means what? Conflict means creating a problem. Okay, so we have to search a pair which create a problem or which cannot create a problem. Which will create the problem, it called as conflict pair. Which will not create a problem, it is called non-conflict pair. Okay, now this pair read operation on A account, same time if it is write operation on another, it will create a problem, right? So all these three are conflict pair. At the same time we cannot read the same account, we cannot write the accounts, right? Similarly we cannot write, we cannot read, we cannot write, we cannot write on the same account. So whenever these two operation going to perform, this will create a problem. That's why this pair is called conflict pair. Similarly we will take some example, read operation and read operation. Both transaction had read operation, so there is no problem. So all these pairs are non-conflict. Okay, by applying these pairs, we cannot, or we don't get any problem while the transaction. Okay, so let's see with an example. Now we have taken two schedule, one which is in a parallel form, another one is in a serial form. Now when we are going to draw a graph for this, what will happen? Suppose T1 and T2. Okay, so first T1 transaction will operate on read and write, then it will goes to T2, again it will goes to T1, right? So there is a loop. Similarly in S dash schedule, what happened? There is T1 and T2. T1 complete the transaction, then it will goes to T1. So there is no loop. So this schedule is in serial form, this schedule is in parallel form. Now we have to solve this schedule to make it equivalent to serial schedule. Okay, so how to solve this problem? We have to, whatever the end of the operation is there, we have to check the adjacent operator, and whether this operation is non-conflict one, we will swap it. Okay, if that both the operation in a non-conflict pair, then we will shift it or swap it. So we will check for these two operation, adjacent operation. Okay, let's check read B and write A. So what is read B and write is a non-conflict pair. So if it is non-conflict pair, you will going to swap it. Now how it will become? So T1 and T2. Okay, so R of A, write on A, read on it. Now we have to swap it, then read of B, and here is write of A. Okay, R stands for read, W stands for write. Now we have solved, swap these two operations. Now again we will check the adjacent pair. So read B and read A. Now check it. So read B and read A. Again it is what? It's a non-conflict pair, right? Now we will again swap it. Now T1, T2. So what will be the output? RA means read, write A. We have to swap it. Then R of B means read of B, R of A and write of A. Okay. Now see. Now we will check. So it is in the form of serial. This is our aim. Means we have to check whether that schedule should be equivalent to a serial. Now we will get this output. So S schedule is equivalent to S dash schedule. Okay, so we can say it is a conflict pair. Okay. Now what is the definition? If there is no loop, that is a conflict serializability. It should be in a serial form and it should be a consistence. Now what next? If, as we have swapped non-conflict pair, right? Now what happened when we go through, suppose there is one another schedule T1 and T2. Now we will check whether these two adjacent are in a form of non-conflict pair. Now WA and read A. So let's check it. WA and read A. But these are what? Conflict pair. These are conflict pair. As we know, when we are whenever the both the operations are in a non-conflict pair, that only time we can swap it. But what about when both the operations, adjacent operations, are in a conflict form? To solve this problem, we have another type of a serializability, that is view serializable. Okay, so what happened in that? Let's see another example. In a schedule, we can have n number of transaction. Okay, so we have taken two schedules similarly. One schedule consists of a 3 transaction. Okay, now we will draw a graph for this transaction T1, T2, T3. Now what happened here? First transaction 1 execute, then it will goes to transaction T2. Again from T2 it will goes to T1. Again from T1 it will goes to T3. Now as the loop occurs, that means it is not in the form of serial, right? So it is in a parallel form. So what about this schedule? Similarly, we have taken 3 transactions T1, T2 and T3. Now draw a graph for the same T1, T2 and T3. Now what happened? Once the transaction 1 execute, it goes to T2, then it will goes to T3. T1, T2 and T3. So there is no loop, means this schedule in the form of serial. Now what we have to see, what do you mean by view serializable? The definition of view serializable is what? Two schedules with the same set of transaction. Now suppose transaction 1 operation on detect, suppose A having initial account of rupees 100. Now the aim of T1 is deducting 40 rupees, T2 is deducting 40 and T3 is 20. Suppose these are their operation. Similarly for S dash also 40, 40 and 20. Now we will apply the operation. Now initial there is a 100 rupees in a account A. Now what will first T1 transaction do? It will read the amount of A. Now it goes to T2. Now what happened here? It will detect 100 minus 40. What will be the output here? 60, right? Again 60, it will goes to transaction T1. Now it will detect, what is the aim of T1? It is detecting 40 rupees. Then it will detect 60 minus 40. Then the remaining amount is 20. Now after this it will goes to T3. Now 20, what is the aim of transaction T3? Is deducting 20 rupees. Then 20 minus 20. The initial account was 100 and the end of the transaction, the value of A is what? 0. Okay. So this schedule is in the form of parallel schedule. The output is A equals to 0. Now same we will apply on a serial schedule. Now initial cost is what? A equals to 100. Now first it will read, that is A equals to 100. What should the write? We have to detect 40 rupees from the initial amount. So 100 minus 40. The output will be 60. Now it will goes to transaction T2. Now what happened here? Whatever the output is there, it will detect from that, that is 40 rupees. So what will be the output? 20, right? Again it will goes to transaction T3. So what the aim? Detecting 20 rupees. So 20 minus 20, what we will get again? A equals to 0. So as the schedule is not looking similar, or if the one schedule in a parallel form or another schedule in a serial form, the output is what? Same, right? So this is called view serializable. Understood? Understood what do you mean by conflict and view serializable? Let's have a look once again. So serializable means what? Simple, we have to see whatever the schedule is, it should be in a form of a serial. Now what do you mean by schedule? Schedules are number of a transaction. Okay. more than 2 number, it can be a 2 transaction, 3, 4, 5, 6 and number of transaction over there. Okay, so this is one schedule, this is another schedule. This schedules having two operation, that is read and write operation, right? So this schedule in the form of serial, and whether this schedule is a parallel. So what do you mean by serial and parallel? Serial means creating no loop. While we are going to draw a graph, that means there is no loop, while in a parallel we have to create a loop. So once the loop created, we have to solve this problem, we have to convert this schedule in a serial form, right? To solve this problem, we have one type, that is conflict serializable. Now what do you mean by conflict? Conflict means problem. Okay, so we will take the pair of conflict and non-conflict pair. Conflict means, as I told you, conflict means creating a problem. At the same time, we cannot read and write a same account. As we have taken an example, if we are going to detect a money, we cannot write and read at the same time, right? When we do this operation, it will create a problem. So that's why these pairs are called, these three pairs are called conflict pair, whether rest of the pairs are non-conflict. Okay, so we have taken one example. Now this is in a parallel schedule, this is a serial schedule. Now to solve this problem, we will check the adjacent operation. If that two pairs are in non-conflict form, then we will going to swap it. Okay, so we will check whether read B and write A is in conflict form. Yes, both are in a non-conflict form, so we will swap it. We have swapped it, we have write it as it is RA WA. Instead of this, we just swap it. Okay, now again we will check the adjacent one. If they both are in a non-conflict pair, then we will again swap it. Okay, so check it, read B and RA. Read B and RA both are the non-conflict pair. Okay, so we will swap it. So we will end of this, we will get in the form of serial. So what the conflict serial says, if it is in conflict equivalent to serial schedule. Okay, we get this schedule in the form of serial, so we will solve this problem. Now next is what? If that two pairs are in not a conflict pair. Okay, if that two pairs are in a conflict pair. So solve this problem, we have another type of serializable, that is view serializable. Okay, in that, in a look, we see both the schedules are in a one is a serial form, one is a parallel form, but the output of both the schedule are the same, right? So the definition of view serializable is two schedules with the same set of transaction. Okay, understood? Thank you. Bye bye.